Um, how are you, everyone? I hope you guys are doing well. I'm also doing fantastic, very good. So I just decided that this could be of importance that I just go through um Ajak 210 test 2 that was written last year, right? So to give you a good um catch on what exactly happens when the questions are being asked and how you must or you can answer such questions if they come, right? So let's get to it. Okay, so right, do you remember that we done a problem that was based on the MIRS substitution, right? The input substitution. So I've got another problem which double links with the problem that I've dealt with, right? So this one have two. This is question 4. This was question 4 in the last year paper, but I've just bring it back. So you see, it's 20 marks, right? So you may see what happens is that these questions could come in a format that you have to define the marginal rate of input substitution. Show its mathematical representation. And you know, it is what? It is a change in x1 over the change in x2, right? Because it is based on the input substitution, not the product substitution. Get that? Then we have to differentiate graphically the 3 possibilities of relationship between the inputs. You must remember the perfect substitution, the imperfect substitution, and the complement, you know. But I will also go through that on its own, right? Because I know and I understand that you guys are going through a lot. So here comes the problem then. This problem says Life owns and manages a chain of bakeries, and he needs to decide the best combination of relatively costly industrial ovens and bakers at a new bakery. The table below displays the different combination of capital or industrial ovens and labor or bakers he can hire to bake the cakes that the bakery produces. If the bakery puts 20 industrial ovens, right? She will need to hire one baker to use the oven to produce the cakes. Then, that's in this case 5 industrial ovens for each baker, which is a total of 4 cashiers. You see now how this thing has come out. Now, the assumption is that the cost to rent, operate, and maintain an industrial oven for a month is 1,000 rand, and hiring a baker cost 1,600 per month. The table below shows all the cost of each factor input combination. You are asked to calculate the cost of each combination of the factor input and assist the line to make a decision in selecting the least combination. Here's the baker and the industrial ovens. Here's the capital or the industrial ovens, 20, then requires how many bakers or the bakery, then it's 4, 10, 10. Then this is how the question usually comes out, right? Could come in any problem. You see the problem that we have dealt with of the fruits, and now it's coming in the case of the bakeries and industrial ovens. But the main concept that we have to look at is that there should be something in a question that tells you that they must be the best combination. They must be the best least combination from the given variables to be to be found, right? So this is the question. Now the question says you must draw and explain a situation when experiencing. You must draw and explain a situation when experiencing a decrease in marginal rates of product substitution in a competitive product. Then you have to state two important criteria which are needed in choosing an optimum combination product. That one is question 5, but I think it was a question that was changed from this one. But this one was just like this. Then C, then you must perform all the necessities. No one will tell you. You just need to find the best. The question you see, it doesn't even tell you that you must find the best, the least combination. It's just a statement. Then they give you maybe 10 marks. So you must know how to do that. So that is why, guys, we are here. So I'll stop sharing this and go to how the problem must be solved. Stay. All right, back. Okay, I'll go straight to that problem. Okay. All right. So what happens? Remember what we do with the variables. So this is the first variable. We multiply it by its price, and this is the second variable. Then we multiply it by its price. So to find the isocont line, then isocont line, in this case, we have to multiply it. So let me double check exactly where is the twin coming from. Okay. So therefore, all right, I want it to be like this so that it could be easy for you guys. If we visible, try for you to see. Right, perfect. So we really want to find the cost. So remember that that 1,000, that 1,000 came from what exactly? So the assumption is that the assumption is that the cost to rent, operate, and maintain an industrial oven for a month is 1,000, right? So that is the cost to operate in the industrial oven for a month. It is what? It is 1,000. And hiring a baker cost is 1,600, right? So given 4 bakers, if we have 20 industrial ovens, we will hire 4 bakers, right? But per month in operating, that's this industrial oven that we're speaking about, right? It is costing the company 1,000 rand, which means now if we have 20 industrial ovens, we should say 20 industrial ovens multiplied by the cost that we will go through as a company in operating in this oven. So that's why we have to say cost is equal to 1,000, which is the amount that we must pay since we are operating this oven for a month, right? So it's 1,000 times 20, then plus 4, which are the bakers that will operate these 20 industrial ovens. Then we have to add them. We've got 20,000 plus 6,400. Then we find that the relatively least possible cost is 26,400, right? So remember that in that table which says baker and industrial ovens, we are given the grid for capital, which is 20 for capital, inclusive of industrial ovens. Then we are given 20, and we're also given 10. And we're also given the bakery or the bakers, which is 4 and 10. So this actually means that if we have 20 industrial ovens, they will be operated by how many bakers, or the laborers will be operated by 4 bakers. But if we also have 10 industrial ovens, they will be operated by also 10 bakeries. So what exactly is happening here in this business is that they want to know the least combination in making sure that they do not go through losing a lot of money, maybe in now hiring more of the laborers that will exceed the number of available industrial ovens, right? Since these industrial ovens, they also have to pay for them, for their operation, which is 1,000 rand. So you can imagine such a story, such a case that you are operating something, maybe you have borrowed it, right? Then you also need someone who will operate it. So if you have borrowed something and you have to pay for it, you don't need to hire large number of individuals to operate it, and you also have to pay those individuals. So that is where the concept of the least cost combination comes in this life owns a company and manages of a chain of a chain of bakeries. So that is where we want to find a least cost combination, right? And taking you back, because could be that others haven't exactly what is happening, right? Okay. So I want you guys to get it exactly. So you see what is happening now is that this is the baker and industrial ovens. What happens here is that we do not need more bakers than industrial ovens. And also, we do not need more industrial ovens than exceeding the number of bakers, right? So between these two intrinsic factors, we must find a least combination, right? And we also need to hire a baker, which costs 1,600 per month, which is also expensive. And we also, in that very same time, we need to maintain this industrial oven for a month, which is also 1,000. So you know that if the assumption is that one oven will be operated by one baker, or you say 20 ovens will be operated by 4 bakers, or you say 10 industrial ovens will be operated by also 10 bakers. This is more like going to fish and chips when you're about the store nearby or honchos maybe, but there's fish and chips if you're about to get to Scotland Mall, right? If you get there, you find that there are bakers there, right? But in those, if the workingness of those bakers is that they have a certain list combination in how they have to work according to they have the industrial ovens that they're making use of, which are more efficiently maybe in production of pizzas. But if it happens that they have more bakers than the available ovens, they have to reduce the number of bakers so that the ovens will be more corresponding to the people that will put it into function, right? And if it happens that they also hire those individuals, it's also gonna be not a good case. It will cost even the manager efficient chips, right? So that is where the overall concept of finding the least cost combination, that is how it's taking place, guys, in reality. Then remember that we also have to find the least cost combination for 1010, and also we have found this for 24, for 20 and 4. So let's get back to it. All right. All right. Okay. Back. Hopefully everyone can see now, right? So the first cost was 1,000 that need to be paid for hiring, for maintaining these 20 ovens, plus 4 bakers that are available multiplied by 1,600, which is the amount that is required for hiring just the labor A1. Then that is how we came up with this the least cost combination for the first one, and also do the same thing for the second 1010. Now the least cost combination of one uses the minimum resources to optimize the productivity. Therefore, the least cost is where the number of bakers is equal to the number of ovens in order to minimize possible losses. But due to be in hurry of submitting, I tend to say buckets, not bakers, guys. And this is in 40. Should have been bakers. You know, if you have to submit it within the minimum required time, you make a lot of mistakes. So between these two, you see that, oh, here is the least possible cost. All right. Then I stopped here. I'll just touch this concept little bit.